So features of parabolas. The graphs of quadratic functions are called parabolas. So we've solved quadratic functions. Now we're going to graph quadratic functions. Some things that we're going to be looking at in terms of our quadratic functions and graphing them. We'll be finding x-intercepts. Sometimes parabolas have 1. Sometimes they have 2. Sometimes they have none. So they can have 1, they can have 2, or none. All parabolas have a y-intercept, even if they don't have an x-intercept. Parabolas also have a vertex. Sometimes this value is a maximum. Sometimes this value is a minimum. So a vertex can be a maximum point or a minimum point. Parabolas have direction. Sometimes they open up, sometimes they open down. Some other things that we'll be looking at in terms of our parabola is what's called an axis of symmetry. An axis of symmetry is related to the vertex. It's going to divide the graph into 2 equal parts. They'll be symmetric on either side. And by the way, you don't have to write these definitions down because we're going to look at all of them again in terms of graphing in just a moment. Right? So I have a couple more things that we can look at in terms of our parabola. We can look at the domain. Those are, remember, our input, or the x values. We can also look at our range. That's our output, or the y values. The last thing I saved, this last number here, number 8, is something that we're not going to be looking at. But sometimes our parabolas, they can open different directions. Besides just up or down, we can also have right or left. We will not be graphing these though. Right? So these are not now. The equations for these type of parabolas are different than the ones that we're going to be graphing. Right? So we're going to be worrying about direction up or down. We'll find our x-intercept, y-intercept, vertex, the axis of symmetry, which relates to our vertex, and then our x and y values, our domain and range. Let's look a little bit at our parabolas. We'll start with direction. So the direction of parabolas. Here we have a parabola that is opening downward. We call that concave down. Here we have a parabola that's opening upwards. We call that concave up. So if A is negative, remember when we've been working with solving quadratic equations, and we had equations like, so we had ax squared plus bx plus c, right? We call that standard form, right? So there's our a value, right? So if that is a negative number, the parabola opens down. If a is a positive number, then the parabola opens up. right? So the way you can think of it is when A is positive, the parabola is happy. When A is negative, the parabola is sad, and it opens downward. Or you can think of it like a cup, right? So if A is positive, the cup holds the water, it's concave up. If A is negative, all the water falls out, it's concave down. So I wrote one type of equation on the board. This one is called standard form. We use this one when we're solving with quadratic formula or with factoring. But it is not the only form. And it is certainly not the only form that we'll be working with. And all of them have A values that can be positive or negative. And those going to determine the direction of our parabola. I have some other things, by the way, labeled on this diagram before we leave it. All right, so you can see right here. I'll do my best to make a straight line. And we have the axis of symmetry dividing our parabola. It's 2 equal parts. This parabola has 2 x-intercepts. It has one here and one here. All parabolas have a y-intercept. And all parabolas have a vertex. In this case, our vertex is a maximum. Let's look at the other graph here. It also has an axis of symmetry, and all parabolas will have an axis of symmetry. Notice that that axis of symmetry did go right through our vertex. In this case, the vertex is a minimum. This parabola also has 2 x-intercepts. Not all parabolas will have 2 x-intercepts, but this one does. All will have a y-intercept. So here we've seen a couple different parabolas with different directions. Let's look at, so I said that standard form was only one type of equation for quadratic functions. Let's look at some more. So here are the types of quadratic functions. I believe I put it in your notes. You'll definitely need it. So standard form, f of x equals ax squared plus bx plus c. All right, that is called standard form. The only nice thing about standard, so now we're not dealing with necessarily solving, although that is definitely going to be a part of it. But now we're going to be doing more than just solving. The only nice thing about standard form is that the y-intercept is easy to find. We have vertex form. Vertex form is in the format f of x equals a times x minus h all squared plus k. You've actually seen vertex form when you were solving, and we were solving using square roots. You almost put equations into vertex form when we were completing the square, except we solved and instead of writing it into vertex form. As you can imagine why vertex form might have its name, it's because the vertex is easy to find. It's the values hk. Right? So notice that negative stays with the equation. Right? And so we leave the negative there. That h value, the number that's being added or subtracted to x, that's our x coordinate of our vertex. The number added in, that's the y coordinate of the vertex. So it's really easy to find the vertex. Other equations too, by the way, have a similar format, and they'll have similar rules. So when we learn some rules for vertex form later on, we'll be learning some rules for lots of other different functions as well. So the vertex is easy to find, and essentially it's completing the square form. If I don't just isolate the something squared and solve, right? If instead I move the term back, I will have it in vertex form. And we're going to look at how to write equations into vertex form. It's really nice for equations that you cannot factor to solve with because you'll get the vertex, and in a couple steps you also get the x-intercepts. So that's always nice. The last form is called intercept form. F of x equals x minus p times x minus q. P and q are just numbers, just like h and k. The x's are with the equation. A is a number as well, right? It tells us, one thing it tells us is the direction, right? It'll also tell us the spread of our parabola. So the nice thing about nice thing about intercept form is that the x-intercepts are really easy to find. They're the numbers that are being subtracted from our x there, right? So again, the negative stays with the equation. So if we have a negative, it's a positive value. If we have a positive, it means we have minus a negative, and we'll look at that in more detail once we get to graphing in intercept form. It's essentially factored form. So you have standard form, where you can find the y-intercept. You have vertex form, which is essentially completing the square form, right? Except we just moved everything back instead of solving for x. And then you have factored form, which is what we've been working with quite a bit. They all have things that are easy to find. And actually, if I'm graphing, the one that I think is the absolute easiest, and I have to do the least amount of work for, well, I think it's intercept, followed by vertex, and then standard form. We'll learn how to graph in all three formats. We'll also learn how to change standard form into vertex form. The A in all of them, right, whether it's the in front of the x squared, in front of the x minus h squared, or in front of the x minus p and the x minus q, it determines the direction for all three types of functions. And I really shouldn't say functions. They're all the same function, right? They're a quadratic function. All different types of equations. That's probably a better word. So if I put functions, it's all right. But equations is I think, a better word. All right, so in the next podcast, we're going to learn how to find some different things in all of our different types of equations. All right, bye for now.